Hello students, hope you are fine here. Today's our topic is ratio rate and speed, and as this we will be discussing some of the equation, some of the problems related to ratio. First, we need to know that what ratio is. Ratio is the comparison of two same identities, same things, identities. If we are comparing different identities, then we'll be going for rate, and the same rate is applied in the concept of speed. So speed is actually a rate, but ratio and rate are two different things, in which ratio is the comparison of two same identities and rate is the comparison of two different identities. So, for example, 5 inches and 15 inches. Both are the same identities, so it means we can compare them in the form of ratio, and we can simplify this as 5 ratio 15. And now we can see that by which table these both can be simplified. So we can see that both can be simplified in the table of 5 and the table of 5, the same table. Then we could simplify it. So it becomes 5 ones are 5, 5 threes are 15. So it becomes 1 ratio 3. So in 5 inches and 15 inches are actually in the ratio of 1 ratio 3. So this is about ratio. So first of all, the examples comes in which we'll be giving some of the ratios of same quantities, same numbers. Then we'll be going towards some of the more technical examples. So let's see how it happens. First of all, some lengthy calculation involved question, which is 144 and 148. And we are asked to simplify in simplest form. Simplify in simplest form. Now, how can we simplify this in simple form? So we are looking for those numbers which could simplify both of them. It is divisible by 2 and divisible by 2. So that's why we could divide it in the table of 2. So it becomes 72 and it becomes 74. Now we could simplify it further. It also could be divisible by 2, both of them. So still we could simplify it. It becomes 72 becomes 36 and it becomes 32. Still both can be simplified in the table of 2, and then it means we can simplify it further. It will become 18 and uh, 16. So these both the numbers again could be simplified in the table of 2. So we could simplify it further. So it becomes 9 ratio 8. These two numbers could not be simplified further. So that's why these are the numbers which are in simplest form. Okay. So whenever we have a number, we'll try to seek any number, both the number are simplifying with any of the number which is the same, then we'll simplify. It does not mean one is simplifying with the table of 2 and the other is simplifying with the table of 5, and then we are simplifying with 2 and with 5. No, it's not the way. We'll not be making it because these simplification must be balanced. Means if we are simplifying with this same number, then we must also simplify with the same number on the other side. Then it will be balanced, and then we'll be converting continuously until the end of the time. Similarly, if we have 144 ratio 145, so you can see that I will try to find it out as any number. We could simplify both of them. This could be simplified in the table of 2. This could be simplified in the table of 5, but not both are with the same number. This could be simplified in the table of 3 as well, but this cannot be simplified in the table of 3. So it means we can't simplify with the same numbers, so that's why this is the same simplest form. This is the simplest form already, because this cannot be simplified further. Now, for those numbers which are in fraction, how to simplify those numbers? Let's take those numbers. This is a number which is the simplest number in integers. Now we'll be looking for the fractions. That how we'll be simplifying fractions into simplest form. Now let's take it. This is 9 over 20 ratio 3 over 5. Now, whenever fraction comes, we need to go for LCM to remove the fractions. So what are the LCM? LCM of denominators. So what are the denominators? 20 and 5. So let's take out the LCM. 2 tens are, and it remains the same. It cannot be divided. It still could be divided by 2. 2 fives are, it remains the same. Now can't be simplified with 2. Now 3. No, it could be simplified with 5. Ones and ones. Both are ones, so that's why our LCM is 20. 2 into 2 into 5 is equal to 20. So now we have seen that LCM is 20. So it means we'll be multiplying each term of 8 by 20. Divide by 20, multiplied by 20. And this gives us a simplification of removing of denominator by simplifying. 20 ones are and 20 ones are, 5 ones are and 5 fours are 20. So that's why this will give us 1 nines are 9 ratio, 3 fours are 12. But these both numbers could not be simplified with 2, but we may see that these both can be simplified with 3. So what comes then? If we simplify these both with 3, so it becomes 3 threes are 9, and this becomes 3 fours are 12. We are dividing by 3 to get 3. We are dividing by 3 to get 4. But these numbers cannot be simplified further, so this is the simplest form of this fraction, which was 9 by 20 and 3 by 5. This was the question which we have simplified into the simplest form. So whenever fraction comes, we'll be using the LCM method and LCM of denominators, and whatever the LCM will come, we'll be multiplying with the LCM term, LCM number, with both of the terms, right, both sides, and this could simplify. And in this simplification, what would happen? The denominators will be simplified. So that's why we'll be getting some more simplified numbers, integers numbers, and these could be simplified further if possible. If could not be simplified, then that will be the answer. But here in this case, you can see that these both can be simplified in the table of 3. So we simplify it further, and if there's possible, then we could simplify further. But here, these are numbers which could not be simplified further, so that's your answer. So this is a fraction technique. Now, come to the another one, which is about decimal. So how to simplify decimal? So let's check it. The decimal numbers are 0.09 ratio 0.21. Okay, these are the two numbers which are simplifying here, and what to do here? We will be removing a decimal point. How will remove decimal point? As usual, we have done it in previous classes that we remove decimal point by putting 1, and after the decimal point there are two digits, so I'll be putting two zeros, and ratio is the same. And now decimal point will be removed by 1, and there are two numbers, so that's why we'll be putting two zeros. So now it becomes 9 by 100, because 009 means 9, so there's no need to put zeros, by 100, and 21 by 100. So simply both have this denominator 100, so the LCM will be 100. So that's why we'll be multiplying each by 100 and 100. So it will cancel and gives us 1, 1. So now 1 9s are 9 and 121s are 21. Now these are the number, but we can see that both the number could be simplified with the same number, which is 3. Could be simplified with 3. So that's why its answer is 3 3s are 9 and 3 7s are 21. So this is the simplified form, which is the answer of decimal number. So our question was 0.09 ratio 0.21, which is in the form of 3:7. So like this, we can simplify this fraction. Now, the same unit, but not same identities, but not in the same unit. So we'll be solving those questions. So let's check it. Those which are the same identities, but not in the same unit. So let's check it how we will find those. For example, we have a number of 45 cents and $2. Here you can see that this is in cents and this is in dollars. So first thing we need to do is to look for the number, the unit which is the smaller unit. So which unit is the smaller, dollar or cents? So you can see that the cent is the smaller unit and dollar is the bigger. So we will be converting the units into smaller units. Convert into smaller unit. So it means this will be converted into smaller. This is already smaller. So we'll be writing the same here. 45 remain the same. But how many cents in $2? So we know that there are 100 cents in $1. $1 is equal to 100 cents. So $2 means 200 cents. Now the units are same. Quantities are also same, means currency, and the units are also same in cents. So that's why now we could compare both of them. So it is now 45 ratio 200. 45 ratio 200. Now by which table we could simplify both of them? So we'll be dividing it both by 5. It could be simplified with the table of 5. So it will become 9. It will become 9. And the other will become 40. So 9 ratio 40 could not be simplified further. So this is your final answer in simplified form. So you can see that whenever the units are identities are same, but the units may be different. So what we do, we'll be converting the units into the smaller unit, and then the units will be the same also, and then we'll be simplifying to convert into the simplified form. Now, like for the another example, here is the question of writing 7 by 200 meter ratio 105 centimeter cube. This is about the liter, this is about volume. So density cannot be compared with the centimeter cube, but we must know that 1 centimeter cube is equal to 1 milliliter. So it means we could write this as into milliliter. So that's why our question will become then 7 by 200 liter and 105 milliliter. Now the same identity means liquid and the liquid. Now liquid can be compared, but the units are not same. This is a liter and this is a milliliter. And this is a bigger unit and this is a smaller unit. So what we convert? We convert into smaller. Into smaller. So it means it will remain the same. It will be changed. It will be changed. So how many liters, how many milliliters in 1 liter? We know that there is 1000, 1 liter contains 1000 milliliter. So in place of liter, we'll be writing by 1000, then it will convert into milliliters. So what we do that 7 by 200 into, now liter is converted into 1000, so we'll be write 1000, now it becomes milliliter. And on the other side it was 105, it's already in milliliter, so there is no need to change. Now this could be simplified further, so 0 cancels, and now 2, with the table of 2 it can be simplified. 2 ones are 2, 2 5s are 10, so 7 5s are 35, 35 ratio 105 milliliter and milliliter. So now we can simplify it. With the table of 7, it could be simplified, both of them. The table of 7 it is simplified. So we'll be writing it as 7 5s are 35 and 7 1s are 7 and 7 5s are 35. 5 and 35. And now could it be simplified further? Yes, with the table of 5. Yes, 5 with the table of 5. So this will become, sorry, you can see it, this is table of 5. So This could be simplified further with the table of 5. So 5 ones are 5 and 5 threes are 50. So the conversion of 7 by 200 liter into ratio into 0.105 centimeter cube could be written as 7 by 200 liter in ratio 105 milliliter, because centimeter cube is equal to the same milliliter. So that's why we have converted 7 meter cube into milliliter. Now the units are not same, so we converted bigger unit into smaller. So that's why liter, in 1 liter there is 1000 milliliters. So that's why we converted the liter into milliliter by multiplying into 1000. Remember that whenever we are converting bigger unit into smaller, we multiply. And whenever we are converting smaller unit into bigger unit, we divide. So divide gives a big confusion, because it includes decimal, and decimal multiplication gives much more complications. That's why we avoid it. So that's why we try to convert into smaller unit rather than converting into bigger unit. Though it's also possible to convert into bigger and to solve, but this will involve decimal. So that's why we are not using this, and we are using the technique of converting into smaller. So this is your answer. Okay, hope you understand this. Now, there is a problem related to that, but before this, we'll be going for the continued fraction. There was a topic of two fractions, but whenever we see a fraction of more than two numbers, two identities, then how to solve this? So let's check it now. If we have a number like example, a number which is 108, 36, and 60. So there are three numbers. We need to see that whether all these three are divisible by the same number. Yes, you can see that this is divisible by 2, divisible by 2, and divisible by 2. If any one of them is not divisible by 2, but the rest of them are divisible by 2, we will stop this. We have to see the number by which all of them are divisible. Then we will simplify it. So now in this case, this now becomes 54 by dividing by 2. By dividing by 2, it becomes 18, and it becomes 30. Still, this could be simplified, divided by divisible by 2, and divisible by 2. So let's check it what comes. It becomes 27, 9, and 15. Now, these two could be divisible by 9 and 3. 9, but this could not be simplified by the table of 9. But this is divisible by 3, and divisible by 3. So that's why its answer would becomes 9, 3, and 5. Now there's no number which could divide all of them. So that's why this is your answer in simplified form. Okay. So in this case, you will be solving like this. Now solving the problem related to that is about a fraction which in which some of the numbers are given and some are not given. So let's check it. Problem. I'm writing one of the problems here. 3:9. Is equal 4:8. Now, this ratio problem also gives us that this could also be simplified into the form of fraction. This could be converted into the form of 3 over 9. Similarly, on the other side, this could also be simplified as a ratio of 4 over. These are in the form of fractions now, and we can do here as cross multiplication. And in this cross multiplication, what we can do, we can see that there is 3 multiplied by a is equal 4 multiplied by 9. Now it gives us 3a is equal 4 nines are 36. Now there's an equation now. In this equation, you can see that a is multiplied with 3. So that's why we may divide it by the same number. And to make it balance, we'll be dividing in the same number. So it can simplify it here. A is equal, it can simplify here as well. 12 is equal to 12. So we found the value of A in this fraction. So this is the ratio, and now we'll be discussing about the topic of rate in the next lesson. Until that time, we are discussing ratio about it. Hope you understand it. If you have any query, you may ask me. Thank you.